Obviously, glaciers are a large mass of ice that's stored on the land. So one thing to know is 77% of the world's fresh water is actually frozen ice. And so most of the fresh water on Earth's surface is not rivers, not lakes, but actually stored on the land in the form of glaciers. Where we're going to find them, we're going to find in two key areas: high latitudes or polar areas, places that have a latitude close to 90, but also places that have high altitudes. Key idea there is for us to have ice, obviously we need bitterly cold temperatures, and so this relates to weather and climate ideas. Where we're going to find them, we're going to find them in Antarctica and Greenland, or the highland, more mountainous areas like the Rocky Mountains and the Himalayas that are quite tall mountains that poke up quite high. Two key places where we're going to find glaciers. Another key characteristic of glaciers is they form, or their glacial boundary, let's say, is what we call the snow line. Simply put, that's the latitude or the elevation that winter snow can last the entire year through the summer and back into the winter. And so this is essentially when the glacier, the kind of the edge of it, where the glacier remains ice for the entire year. One characteristic is currently the world's glaciers are actually retreating. So what that means is glaciers are actually shrinking. Now this could be or could not be because of what we refer to as human-caused global warming, but we know no doubt that glaciers over time have had these periods of advancing and retreating way before humans were here. And this is note, and we'll flesh this out a little bit later on. The main contributor to understanding why sea level is rising currently is the fact that glaciers are melting. These glaciers, and so essentially you have water that's stored on the surface on land in the form of ice, is of course now melting and running off and going into our oceans, causing the sea level to rise. The photo in the top is from 1914, the photo in the bottom is from 2009, taken from the same exact vantage point. And you'll note that you can see the retreating glaciers in this comparison. If global sea level would rise just 1 meter, or about 3 feet, the areas in red would be underwater, indicating the vulnerabilities much of the United States is, especially where our densely populated areas are, along these coastlines to global sea level rise. Same idea, but for Florida. And then finally the Louisiana coastline. Let's relate this to plate tectonics. And so here we have on the right-hand side all the continents pretty much all together along the equator, whereas in the left-hand side we see them broken apart. So how will that play a role in global sea level? If we just simply come up with the idea that, of course, on the left-hand side, we're more likely to find ice stored actually on the Earth's surface in the form of glaciers, where along the tropic areas, of course, we're not going to have ice. So if we look at the image or the globe on the left, the idea there is that's going to cause sea level to actually go down. So sea level will go down, as in this case on the left-hand side, the water is now stored on the Earth's surface rather than being in the ocean. So on the right-hand side, you're going to actually have, because of the position of the continents, you're going to have a higher sea level, or sea level is going to be at a higher elevation. All right, time for some complex animations to showcase glaciers. Now let's pretend that we have a glacier here. So here we have a large mass of ice. So over time, this large mass of ice is going to get bigger. Why is it going to get bigger? Continued snowfall. So one of the things is snowfall continues to occur. So you have high precipitation, but it's very, very, very cold. So that snow is going to accumulate, but as it accumulates on top of previous snowfall, previous layers, it's going to then compress the bottom. So one of the things you'll notice, you'll find at the bottom of a glacier, towards the bottom half, it's essentially solid ice. It's become compressed because of all that weight from all of that snow above it. And keep in mind that these suckers, especially continental glaciers, were in places 1 mile from the surface up. And so if you can just imagine seeing 1 mile from where you are up being nothing but a sheet of ice, of course that's going to do a lot of damage. And so this extremely massive, powerful eroder is going to cause landform change. It's going to cause the landform, in this case, to become compressed below it and actually create a depression. But we note this, that the glaciers, they've been retreating for a long, long time. And so one of the things to note is we see features that are left behind from these glaciers that are no longer. And so essentially we have these features that are now revealed once all that ice melts. That area that was once depressed by the huge weight of ice sheets during a most recent glacial period, actually that depression starts to rise. And so currently Michigan, but also much of Canada, the crust is rising because no longer is that weight from that glacier overlying that area and causing the depression. This is a term that is called isostatic rebound. So the experts call it.